Howdy, welcome to another SSA video. This one's going to be on inlet design, how to do it well. This is going to be kind of a intro to doing inlet design. I'll do a kind of a more thorough one later on, but let me just get started. So I'm going to start with a blank Civil 3D drawing, open my tool space. I'm actually going to bring in a storm pipe network. Now you can right click and import, or you can just do what I did, drag and drop. I'm going to pick proposed storm sewer, do ZE for zoom extents, which will zoom right to where I want. And one pretty cool thing that I can do here is if I go back in to the network itself that's now in my drawing, I right click and I promote it. Now it's living in my drawing. I can manipulate it, I can delete it, I can edit it as I want, but it's not going to be linked to the rest of my project. So I don't really need all of these storm sewers for what I want to show you today. So I'm going to delete some of the ones that I don't need. Delete some of these ones. I turn on the geolocation so I can see where I'm at. I know, for example, I have an extra little pipe in here I don't want to bring in. Okay, I think this will basically serve the purpose that I was hoping it would. I'm going to bring in my base file just so we can kind of see what does the rest of the project look like. Bring in my line work project. I'm also going to bring in my drainage basin boundaries. So I'm going to right click, select similar. I'm going to do Shift Control C, which does copy base point with a location. Do 0, 0. I could also have done that by right clicking. I click that, right click, clipboard, copy with base point. Go back over to my drawing that I'm going to use to import. I'm going to do Control V for copy, put it at 0, 0. And now you can see I have just brought in those basin boundaries. I'm actually going to isolate this layer and delete some of the stuff that I know I'm not going to need. I can delete more of these when I get into SSA, but it's quite a bit simpler to do that, to delete part of the drawing when I'm actually in CAD. Now that I've got my basin boundaries in and somewhat edited, I'm going to go in here and actually click on the pipe network. It doesn't need to be promoted to do this. You can actually do this even if it's data shortcutted in. I'll click on Edit in Storm and Sanitary Analysis. Now this is going to import storm sewer analysis. It's also going to bring this entire drawing in to SSA, which is good and actually mostly bad in my opinion. It's good if you've kind of done a one-off drawing, but if you're bringing in a drawing like I did, which is something that's used for other parts of the project, you can actually lock up that file. So I'm gonna go in. The first thing I'm gonna do is actually go in. You can see it brought in all of these background files. I'm gonna go in here. While it's really convenient to see things, I'm gonna go in and pull that out. And if I were you and you really want to have that in there, I'd make a one-off file. I'd bring in just the information you need and then have it so it doesn't matter if it's being affected by something else. So I'm going to go in here, I'm going to unload that CAD file that I brought in. There we go. And you're like, oh man, I really like seeing that. Well, sorry. You got to make a one-off file if you want. So I'd bring in all the layers from your line work file into one file that you don't really care if it's locked up. And by locked up, I mean someone else is trying to use that file, but you can't edit it. So it's in use, if you will, by SSA, which is not what we want. All right, so let me go back to my CAD file, and I'm going to bring in these drainage basin areas. So to do that, I'm going to type in map export, which is basically a pretty cool way you can bring in GIS type data. I'm just going to put it on my desktop, call this SSA Basins. All right, and I am going to, you know what? I'm actually going to isolate this layer before I do this. It'll be a little bit easier. And the way I'm doing that is I'm just typing lay ISO, or I've set it to a shortcut key. If I type 1 and hit enter, it does lay ISO for me, but it's the same thing as typing lay ISO. All right, let me go back and type map exports again. But on my desktop, basins, SSA basins. Now I'm going to select manually, and I'm going to pick all these objects. Again, I can delete these once I get within SSA, so you're better off bringing more than you think. 18 objects selected, but it says 18 filtered out. And the reason it's doing that is because there's a special option you have to select, which is treat closed polylines as polygons, which I can't pick for some reason. Go in here. I guess I gotta collect the polygon first. So one of them is being filtered out. I'm not really sure why that is, but hopefully it's not one of the ones that I need. Now I'm gonna go back into SSA, and I'm going to import GIS imports. I'm actually gonna select subbasins. Go to my desktop, SSA basins. And it's giving me acres. And width. So I'm gonna hit finish and import it. And here you go. You can see I've got a few more than I need, but I think that's okay. So you can see like this one up here, I'm not actually gonna need. I can right click on this and either hit delete, or if I hit L, it should just delete it. Delete a couple of these. I could also go in here and delete it from here. You can see it's highlighting that one, sub 02. All right, now I should need the rest of these. So what I'm gonna do here is I'm going to right click on this. I'm going to connect these to this inlet. Could also hit C here and click it. Same with this. Now I have kind of these extra inlets built in. These are kind of redundant C for my system. I'm going to actually just delete these for the purpose of this example, because I'm not trying to assume those are going to be functional. I'm trying to assume those are backup in case this inlet fails. Now I'm going to connect this basin to this inlet, connect this basin to this inlet, and vice versa. Here we go. Connect this one to this one. All right, I think I have all my basins now connected to inlets. Actually, these two I almost forgot. Okay. All my basins should now be connected to inlets. Now let's actually go in and we need to convert each of these junctions, which is how they come in from Civil 3D, into inlets. Now I'm going to convert to right here, V inlet, VI. That was not what I wanted to do. Too many shortcuts can sometimes shortcut you to the wrong thing that you weren't trying to do. VI. There we go. VI. 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 All right, we need to have an outlet in our drawing, which we do. These should all be sloping the right direction. Now, if your pipes aren't built in properly into Civil 3D, you might run into some inlet, outlet, elevation issues, which we might still because we copy this into a different drawing, but we're going to run it a little bit and see how it goes. Now, what I really wanted to show you today was how to do inlet and inlet bypasses. Now, these inlets, there's two different types of inlets that you can do. Basically, you can do what's called a on-grade inlet or an on-sag inlet. Now, a sag inlet is basically at your low spot on the road, which maybe I can show you real quick. All right, so we got our road. Here's our low spot in our road. Now we also have an inlet here, inlet here, an inlet here, and an inlet at the bottom. Now water, get my little paintbrush here. Water is going to go into this inlet, but if there's a big summer event, some water might continue onto this inlet, and then it'll go into this one, and then some water might just continue on it and go into this one, and then some water continue on, and then this is kind of like your fail-safe. Water is going to back up and pond before it finally goes in here, or it might even pond up so much that it's going to go back into this inlet. And that's why we have those couple of redundant inlets that I was showing you from the beginning. But in SSA or in Calcs, the way you want to model this is you want to have, if you have an on-grade inlet, you need to also have an extra, like, where's that water going to go if it doesn't all go into this inlet? And the answer is, I'm going to set this as on grade, and right here it's going to say roadway gutter bypass link. So where is the bypass? Where's water that doesn't go into the inlet? Where's that going to go? So we actually only have one link out of this, which is this D301 to D302. And actually, let me show you one other thing that's really handy for this. I'm going to go into right-click, display options. I'm going to turn on my link IDs here, and that is going to show us what the name of these links are. And I can actually also turn on my inlet IDs as well, which I'm going to do. Subbasin, no, not subbasin IDs, node IDs. Here we go. And so you can now see D301 and D302. And you might be wondering, how did you get these sweet names? There is a really cool tool within SyncPack 2, which is called Pipes Renamer. And you can rename all the pipes based on the name of your inlets and junctions, which is pretty cool. Anyways, getting outside myself here. I think I might have forgotten to connect this one to this. So let me do that really quickly. Okay, so what I'm going to do now is I'm going to come and draw in these bypass links. So I'm going to basically draw in from here to here. I just drew in link 1. I'm going to draw in link 2. I'm going to draw in link 3 here. Actually, that's wrong. I'm going to delete that. I could flip the size of that, but I'm actually going to draw it in the right direction so that it automatically knows where it's going from the upstream to the downstream. And that looks like all of the bypass links that I have. So I have 6 inlets in my drawing. And these will be grade inlets, and these 2 right here are going to be sump inlets. They're both going to travel to this low spot here. So I'm going to first come in here, and I am going to double click on this inlet. I'm going to make this a sag inlet. And I'm just going to stick with the defaults for now. You might have different values. Like I know, for example, the inlets that we typically do, I believe, are 30-inch by 24, or sometimes they're 20-inch by 24, but I'm just going to stick with that 36 by 24 just to start. I don't even have all my inlets in, so this isn't really a fully functional model, but it will definitely work for what I'm trying to show you today. So these should all be set up. Another thing, I'm going to come in here and I'm going to double click, and this is where I'm going to set my link 2, which is going to be my roadway gutter bypass link. And actually, you know what? Now that I did that, I need to come in here and I need to set my upstream road length to link 2, and I actually need to set this one to link 5 as well. So the water is going to leave this one, and then where is it? What is there any water coming to this one from upstream? And the answer is yes. Okay. Same with this one. I need to come in here, and if you can understand how if you have a really big drawing, this would take quite a while. You have to set all your links, and if you have them wrong, your your results are not going to be accurate. So I shouldn't have any upstream link here, but I should have a downstream link. And you can see here, if I had more inlets up top, these ones would have a downstream link and an upstream link, which I don't have in this example, but if I do a future longer example of this whole project, then I would include that as in there. Okay. So here we go. All right, so here's another question. What do you put in for these links? Are they pipes? I have messed around with these quite a bit, and this is one of the trickier parts of SSA. So I don't really mess around with this very much. Basically, what I'm trying to do is I'm trying to do kind of a worst case model. I basically want any water that doesn't make it to this, I want it to make it here immediately, which again, sort of a worst case situation, but that's sort of what we're trying to do here. So what I'm going to do is I'm going to keep this as a pipe. I'm going to make the length, which it's drawn at 213 feet. I'm going to make this 1 foot. So basically, it's going to travel from here to here extremely quickly, and show up here right away, which is really what I want to do. So I'm going to do that for all these. You can see I have link. You can actually just type them in here. 1, 1, 1. I believe I only have those 4 links. And so any water that bypasses here is going to basically immediately make it here, because it's not going to take very far to travel 1 foot. Now, if I had it at 213 foot, there might be a little bit of lag before it makes it to this pipe, which is, I don't really want to model that. I want to model a worst case scenario. Okay, so I should be ready now to run my model, at least conveyance wise. I still need to set up the hydrology for this model. So I'm going to come into my project options, make sure I have all this set up correctly. Now I'm going to do rational method, which is I usually actually run the SBUH or the TR55, but because I'm trying to do a worst case scenario, I'm going to come in and do rational method. For ID labels, I should have all these correct. This can be helpful when you're setting up the model originally, but for right now I don't need it. What I usually do is I take today's date and then I set this 1 day ahead, and so I can have a 1 day model. If I need to change anything else on here, storm selection, and I don't need that. I do need to come in here into my IDF curve, and I'm going to set this to intensity direct, and I'm going to call this is my 100-year event. I think it's 3.2 inches per hour, and hit close. And then, actually what I never did is I never came through and changed my runoff coefficients. So these are set at 0.72. I really want these to be at 0.9. Unfortunately, you can't just change it right in here. You have to go into the runoff coefficient for each one. So unfortunately, I can't copy paste. And actually, you can see these are all set for 5 acres. So this is kind of a little flag for me that I need to go in and recalc my areas. Even though I brought those areas in, it did not seem to calculate them. However, the good news is because this drawing was brought in, from CAD, it should all be drawn to scale. So I should be able to just recalc areas. And I'm putting in 0.9 here in the wrong place. Do that. Okay, so I have all these set for 0.9, which is what I want. I'll hit close. And now I'm going to go into my subbasins. Actually, I think if I just click on one, I can go to recompute area. I actually believe there's a way to do it globally in the entire drawing under analysis, perhaps. Design, recompute areas. Here we go. Now, if I did recompute lengths, it would recompute these lengths of these pipes that I drew in. All right, let's try this again. Now I have much more accurate areas in here. Okay. All right, let's see what happens when I run the model. Is it going to work? I actually think it might not work, but let's see what happens. Oh, error. Here we go. Inlet valid bypass link. D206. Let's see what is going on. Here's D206. Link 02, 05. It's possible they're the wrong direction. Let's see what if that is what it is. This goes from inlet B208 to B206. That should be correct. This one goes from D303. That looks correct. Oh, you know what it is? I didn't set this. It's on grade. I need this to be on zag. If it's set on grade, then you have to have a bypass link. But because it's at the sump, we want it to be on zag. That was our problem. Okay, there we go. Bada bing, bada boom. Now we can go in here and see what sort of analysis options we get. And we didn't get any gutter spread flow, which does not make sense to me. Okay, I think I may have found our problem. Time of concentration for all these should be 5. So 5-minute time of concentration for everything. I'm going to come in here, and for whatever reason, I think this is my problem. It's the areas are so small they're not even generating runoff. Okay, let's try one more time, see what happens. Okay. I did get some runoff, which is good. 2.24 CFS. This inlet had 1.86 gutter spread during peak, which is not that much, which is good. And it looks like you can click on this as well, and you can see, because I didn't have very much spread, I wouldn't have really, here we go, peak flow, barely anything went over that, which is good. Same with this one, 0.02 peak. So I want to show you what might happen. Right now, this has a spread of 5 CFS, so that's actually, or 5 feet, which is pretty significant. This road is not terribly long. There's basically 2 travel lanes, middle turn lane, 2 bike lanes. I think I could get away with probably 12 feet of spread and be okay, but I've been kind of designing it for 8 feet. But let me just show you what might happen if I increase my flow rate significantly. I'm gonna make this 5. Actually, maybe make it 6. Now I'm really gonna hit it hard with some water. This is a good test of your system. What happens when you put this much water in your system? So now, see, I'm over 8 here, and it's giving me a little red dialog. I believe why it's doing that is, if I go under my project options, gutter spread warning, I think over 7, so maybe I want to make this 10. See if I have to rerun the model or not. Here we go. There's no warning. Maybe I need to rerun the model, so it knows that I changed something. Okay, here we go. See, now it's 9 feet. Still not giving me that warning yet, but that's quite a bit of spread. And now if we click on these, it's sending, a lot more water, but still not that much of a bypass. So you can see this is a pretty efficient inlet. It's collecting almost everything. 6.4 feet of spread. Again, it's kind of surprising to me that this is only sending 0.19 CFS if this spread is 6.4, but here you go, peak flow bypassing inlet 0.19. See, those two match up, which is good. So 80% or 85% of the water is being captured by this inlet. Another thing that you probably should be tweaking, your cross slope is probably going to be 0.02. This longitudinal slope is going to vary depending on where you are on the road. If you have a flatter pipe, more water is going to pond up here. If you have a steeper pipe, more water is going to bypass or going to get collected by your inlet, which is slightly counterintuitive, right? You'd think, you'd sort of think that more water you have a steeper slope, wouldn't more water be going by your inlet? But really, what these calcs at least typically, here's your say this is your gutter line. Here's your curb. Here's our inlet. And I guess I just need to draw it in. On a really steep roadway, water is going to fly really quick and hug tight to that curb line, and maybe there's going to be a little bit of water that goes around. On a flatter slope, water is not going to move as quickly, so it's going to kind of pond outside farther, and so you're going to have more water that's bypassing your inlet. A little bit counterintuitive, but that is how the calcs work. So flatter slopes, it's harder to actually capture water in this inlet. The steeper slopes, they will. And that kind of, you kind of think, oh, water's moving faster. You should be able to collect less of it because it's gonna really move really quickly. But you're assuming that the whole of this inlet is so big that anything that touches it is gonna go into the inlet. It's really only water that's gonna go around the inlet that's gonna be missed. There's a bunch of other settings that you can tweak in here, but at least for what I wanted to show you today, that's really the main thing. So I hope this has been helpful, and feel free to play around with this at your leisure. Leave me any comments and questions. I would love your feedback. Thank you very much. Have a great day.